Welcome, ladies and gentlemen, to another episode of Mr. Ballmer's YouTube videos. And now I present you again something very special. What you can see here is DeepMind. DeepMind's website. DeepMind is an AI research company currently under Google Alphabet. So behind modern AI technology which we have today, there is in a broad sense, in a broad way, some AI behind when it comes to technology in many fields. And AI will very likely, well, it will change the world in such a profound way that we will see the world differently from now into the future. What does that mean, differently? I mean, we're creating AI, right? And AI is starting to reprogram, to optimize and write itself. Artificial intelligence is already on its way to optimize itself, writing or making out of algorithms new, much more powerful algorithms, and that without any human intervention. DeepMind is known for, at the moment, especially, well, DeepMind has many applications which they are operating in terms of artificial intelligence, where they apply artificial intelligence or actually building artificial intelligence. But for example, the best pro players, that means the best professional players in some games, already have no chance at all to Google's AI, or actually DeepMind's AI, or AI, what they created. For example, in chess, the best chess player was beaten or actually, let me say it a little bit differently. AI won against the best player, the best chess player or players in the world, and that happened in 1997. So this is about 13 years ago. Okay, 23 years ago. 23 years ago. That's quite a long time. Yeah? Then it beat the best Go player, or one of the best, when not even the best Go player, and it beats in a game called StarCraft 2 also some of the best players in the world by far. And now they're writing artificial intelligence which is actually already many magnitudes, many times better than that AI who beats the best pro players. And this, as I heard, already can play almost, or when not even any Atari games, any games, and master them by its own. And there are many more things which is behind, which artificial intelligence then take over. You can go on the website here and see through. You got publications you can download and watch into it if you're near artificial intelligence researcher, or if you are interested in, if you have to do with AI, for example, also ANN, artificial neural networks, and machine learning, and everything that has to do in some way with artificial intelligence. You get a good source when you go to DeepMind. See here, you can download data sheets. So let's go to let's see what DeepMind has for us in store, or actually what they have. Story, artificial intelligence, who we are. Artificial intelligence could be one of humanity's most useful inventions. That's quite already a statement for itself, right? I read this again. Artificial intelligence could be one of humanity's most useful inventions. Think about this. We research and build safe AI systems that learn how to solve problems and advance scientific discoveries for all. By the way, when you have a modern smartphone, you're already using artificial intelligence in some way or another, which is already built in. Is it when you search something? Is it when you ask Google? Is it when you look at it and it recognizes your iris, your eye, to unlock your phone, and so on and so on, and many technologies. What has to do with artificial intelligence is already built in your current smartphone, and much more to come. So our story. I know that the CEO of DeepMind, which actually a long time ago, years ago, developed a game which has also already to do with artificial intelligence, with some kind of artificial intelligence. And I remember it was the game Black and White. It was called like that, Black and White. There are other games which came after that, of course, but that game was like you were playing some way to treat some animals who had some kind of artificial intelligence or intelligence behavior. So you can look it up. The game was called Black and White, and I think maybe there was two, but Black and White, I remember this one, and there are others as well. And the CEO of DeepMind was involved, who actually developed that game, and probably other games as well. So yes, and they're very interesting things. So now artificial intelligence, because it's also very commonly used in games, also modern games. Ghost Recon Breakpoint, for example, has just introduced or put back the AI NPCs. That means artificial intelligence non-player characters, which will help you as a team go through the world and fulfill some certain objectives to fulfill your mission's goal, or actually to just have fun, or making some strategies that will help you, and you guide it, but they have some kind of artificial intelligence. It's interesting. I also put some videos up for that game to show you what it's about when you play with not only in the multiplayer, actually when you play with non-player characters, NPCs, which have some kind of artificial intelligence. So, recent progress in scientific breakthroughs, real-world impact, and latest research. Let's read this one for a moment. We joined forces with Google in 2014 because Google acquired DeepMind in 2014 to accelerate our work while continuing to set our own research agenda. Our programs have learned to diagnose eye diseases as efficiently as the world's top doctors. Think about this one here. See? To save 30% of the energy used to keep data centers cool, and to predict the complex 3D shapes of proteins, which could one day transform how drugs are invented. Complex 3D shapes of proteins. Oh, this is just like some kind of research they do, and artificial intelligence is helping and is doing that. So let's go to the latest research. What is this about? We work on some of the most complex and interesting challenges in AI. Let me read this again. We work on some of the most complex and interesting challenges in AI. And here you see deep reinforcement learning and its neuroscientific implications. You can download that and you can read it because it's displayed. It's very nice. I like actually that they show you how it is done for the whole world to see, and for some people that they can take their information, their knowledge out of it and apply it for their research, or to advance it and communicate, to share data, to share information and data, that we are enhancing our understanding of actually almost everything we have in this universe, especially our own life, into the future for the good of humanity, or the good of all living creatures. That is probably better to say, right? So advancement is done by sharing information, what you discover, what is your research about, what your findings, your discoveries, your work, and that others can collaborate, and that we are advancing as a humanity in the whole. So our world-class research has resulted in hundreds of peer-reviewed papers, including in Nature and Science. So you can look it up here. You can go to and look it up. Very, very, very interesting source. So explore our research across deep learning, control and robotics, reinforcement learning, safety, theory and foundations, unsupervised learning and generative models. Unsupervised learning, that means that in some way that, well, the AI starting to, as I said, enhance itself, reprogram itself, reprogram the codes, or actually what I read is that artificial intelligence started this year, I think it is 2020, that it is writing or alter its own algorithm to change the structure, to change the algorithm in many different ways and test it if it is better than the current one. And it does this as long as it finds an optimized algorithm, an algorithm which is better in many ways, like faster, more efficient, and so on and so on and so on, that the current one, and from there on it goes on again like this. So it is enhancing, not only enhancing, it is advancing itself with an unbelievable speed. So it is optimizing itself, its code itself, all the time. What is good now can be very old in the next seconds, in the next minutes, in the next hours, in the next days. It is not like that it takes like weeks or month or years, which it took in the past. Now it's coming down to seconds, minutes, and maybe less hours to find, and that's by itself it finds new things, optimize itself, advance itself, and make itself better all the time. All the time. This is a complete new era, and I'm telling you, ladies and gentlemen, artificial intelligence will be extreme. Maybe you don't, maybe you do, and maybe you don't understand this, maybe you understand this, but let me say this. When I say AI will be extreme, because I see in some way what's going on, what is the research, what they do, what is like behind the curtains, as people say, right? So the advances, actually, if you want to, that the money who is put in AI research, artificial intelligence systems, or research in artificial intelligence research is as high as it is. That's like a boom. So many countries putting in billions, hundreds of billions, even trillions, maybe even hundreds of trillions of dollars. Well, let me say, I do not exactly know the number, how much, because the world is quite big, right? But I've seen some numbers, and it's astonishing how much money is put as effort into AI research, artificial intelligence research. So it will be changing the world as we know it from now on into the future, fundamentally. I give you a little example that you understand from what I'm talking about. I'm not talking about this because I think it's fun. I'm talking about this because this is becoming a reality, which is already here. The reality about artificial intelligence is that in the future, as predicted, someday, and that should be not that far into the future, artificial intelligence should surpass human intelligence. I repeat this again. Artificial intelligence should, not that far into the future, surpass human intelligence. And what happened after human intelligence? The intelligence of all humans combined. And what happens after that? Hundreds of billions, or hundreds of or trillions of times the information, the knowledge, the intelligence of all humans combined. So someday it's going into this direction that one day we will reach superintelligence and probably the so-called singularity. Well, you can read this up. I can post some link in the description, which I will, for you to see and to read if you want. It is that thing, ladies and gentlemen. It is artificial intelligence, along with other technologies like the internet, quantum computing, quantum computers. AI is changing our world in a profound way. You have no idea what that means. Of course, unless you see it. And I truly believe you will. Well, for at least for some of you, because we never know, right? Well, that includes me also. So who knows? But the prediction of some people who are working in this field with quantum computers, also artificial intelligence, I remember I saw a presentation of a CEO of one of the biggest quantum computing companies in the world, or some of them. And one CEO said he predicts 3 things. I'm going to the last prediction he made. The third prediction, as he said, well, one of his prediction was as follow. He predicts by the year 2027. And that is, ladies and gentlemen, just if you see the time, the date we have, the timeline, the date we have, this would be just in about roughly 6 years, 6-7 years. He predicts that in the year 2027, artificial intelligence will be taking or can do almost every, when not everything humans can do. Well, let's say even if it is the year 2030 or 2035, okay? But think about this, would be just in 6-7 years. So the progress which is being made in artificial intelligence is extreme. There is, by the time right now while I speak, and today is, well, Switzerland time, or actually Central European summertime at the moment, the 1st August 2020. That's a Saturday. While I speak, there is a robot called Sophia out there. This robot is the first robot ever in history which got citizenship. I repeat this again. There's a robot out there called Sophia. I will post you the description in the link to this video that you can see it. This robot, or actually Sophia, is a citizen of Saudi Arabia. And that means, well, citizenship. You need to may treat that robot like a human with the same rights from the law point of view. I mean, think about it. We have a robot on this planet which has a citizenship of a country, officially. Okay? This is just the beginning, ladies and gentlemen. I saw robots. I saw that in the future, not that far in the future, actually very soon, there should be thousands of robots which have a face which come from a real human. So a real human face in the appearance. They were looking for some participants, and thousands, tens of thousands, hundreds of thousands, well, a lot of people applied to give their face to put it on a robot, to become a robot's face. Somehow. Robot, maybe it looks like then a human. Yeah, it has your face. So, and they paid to that person who was chosen then on the different kind of rules, different kind of requirements they had, or the jury, and that person earned quite a lot of money to give his real face, because thousands of robots, especially then, those robots should be used in elderly care, foster homes, and so on and so on. So in a way of that elderly could see a friendly face and may accumulate to this. So they were looking for a real human face, and robots will have this in the future. So what you see in science fiction movie already, there are many good, actually quite good science fiction movies with robots, artificial intelligence out there. I remember one particularly, but there are others of course as well, many others, but one, I do not want to make advertisement here, okay, but there was one who is called iRobot. There's another one, Antalya or something like that, Battle Angel, so yeah. But there are movies out there with robots and artificial intelligence which are science fiction today. But what was once science fiction in the 50s, 60s, 70s are a reality today. So what you can see as science fiction today may become soon a reality for us to see. Very exciting stuff, very exciting, very exciting. And I actually want to see that, because we're creating artificial intelligence, and artificial intelligence will once create itself. You know what I mean, right? So it's good that we make progress. Ladies and gentlemen, for the beneficial of all humankind. Well, I do not go into details about, there are people who are doing, they are doing good, and some of them doing bad, but for the beneficial of humankind. Okay, so we have a lot of things which are there. Let's go to unsupervised learning, and you got downloads here. Hybrid models for open set recognition. Well, we got a lot of things, deep learning. So you can see a lot of things here. So the impact. We work closely with Google and other experts to find ways for our advances to benefit society, of course, which you already have built in your smartphone when you, for example, using Google search or asking Google. It's getting better and better all the time. So scientific advances, real world benefits, yes, of course, that's what it should be. So far, our system have shown how they can save energy, identify eye disease, accelerate science, and improve Google products used across the world. And if you have an Android device, an Android smartphone, for example, you have Google, because the Android operating system is from Google. If you do not have an iPhone is iOS from Apple, but if you have an Android phone, you use Google technology because it's the operating system on the smartphone from Google. Identifying IDC, I think Google is fantastic in some way. It gives you so many opportunities using tools, technologies in its way for free. You know, look at this, Google Earth, for example, or you can ask Google and it gives you the answer most of the time, actually almost every time, and it's getting better and better. There is voice recognition, there are so text to speech, there are so many things. Identifying IDCs faster, yeah, okay. Saving energy at Google scale, oh, awesome. Improving Google products, yep, good. Understanding protein folding, that's a very interesting part, because this are the founding blocks of life, right? Isn't it? Okay, awesome. To find cure for disease, great. We need this, right? These real-world projects built on our breakthroughs in fundamental AI research, published in journals like Nature, Science, and more. And you can go to it, you can look it up, you can read it, you can listen to it, you can actually go in to see the work, what DeepMind is doing, and so what Google is doing. This is I like that. AlphaGo defeats Lee Sedol in the game of Go. Well, there is the best Go player defeated. Well, what you want to do against the best artificial intelligence? You have no chance at all. You know, because machine and artificial intelligence is so extreme that it will win. It will. Your chance is very low, very low. And this is just the beginning. So there is another alpha, I think alpha 0 or some. So there's advancement already done and beats that artificial intelligence, the AlphaGo, I think by already a magnitude of many hundreds of many times already. So, you know, and that's good. WaveNet, generative model for raw audio. Okay, so neuroscience, representation and rendering. QCN there. Ah, here, Alpha 0. A shading new light on chess, Sochi and Go. Okay. Oh, DQN, human level control at Atari games. Oh, good. Look at this, what I just said, I can read it here. Once the great challenges in AI is building flexible systems that can take on a wide range of tasks. Our DeepQ network, DQN, surpasses the overall performance of professional players in 49 different Atari games, using only raw pixels and the score as inputs. I read this again. Surpasses the overall performance of professional players in 49 different Atari games. Hey, I can tell you this, ladies and gentlemen. I played once together with a friend. Once again against a professional player, and that was in the game Battlefield 4. We are already good. Usually when there is no pro player, professional player inside, we are quite usually good in the score. Okay? We make good scores. We win most of the time, or we do good scores. So we played against a pro player. Okay, I do not want to actually tell you the result, what came out, but the pro player won 30-0 and 31 or 32-1. Okay, and AI is winning on a surpassed. That means it's much better than already professional players in a magnitude of many times. So how a normal player has no chance, or actually almost no chance, against a professional player or professional players, modern AI from DeepMind will win like 5-0 or 10-0 or something like this against the best professional human players in many games already. And there are complex games in some way. Go to StarCraft 2 and have a look. And this is already 1 or 2 years back, which they compete against the best professional players and won like with that score like 5-0 and 10-0 or something like that. Okay, I say this because, come on, it is like this. And the newest artificial intelligence, which was trained, is already many times better than that AI who won against the best pro players at that time, 1 or 2 years ago. So that being said, let's go further on. A neural network with dynamic memory. Oh, interesting. Dynamic memory. Yeah. Okay, but let me read this one here for a second. AlphaZero is a single system that learned to play three famously complex games, becoming the strongest player in history for each, learning entirely from scratch. AlphaZero developed its own distinctive style that continues to inspire human grandmasters. And this is already some time ago. In late 2017. Hey, we are 2020. Yeah, it's mid 2020 already, going into the second. It's already the second quarter, going into the third quarter of the year 2020. Well, think about it. Well, I think we are already second, third quarter right now. The second, the third coming up. Well, let me say it this way. We are in 2020. This was at the end of 2017. Okay? And the world champion in Go was beaten. Almost 3 years later, we have advanced the artificial intelligence. DeepMind advanced their artificial intelligence, which is winning against AlphaZero by a magnitude of many times. Okay, so that the new AI wins 100-0 against AlphaZero, and the new AI wins against that AI with 100-0 who won 100-0 against AlphaZero, and the newest AI win again. Probably it's like this, going up and up like this, winning again like 100-0 against that AI who won 100-0 against that AI who won 100-0 against the AI of AlphaZero. or to AlphaZero. Huh? Think about it. And it will not stop. It will go on faster and faster and better. So former world chess champion Kasparov said, "I can't distinguish my satisfaction that it plays with a very dynamic style, much like my own." And I think that was in 1997, 23 years ago. So think about it. Book Game Changer. Thousands who have analyzed thousands of AlphaZero chess. Says it stands. Oh yeah, that was. When was that? Things that thought itself from scratch how to master a game of chess. Sophia, Japanese chess, and Go, beating a world champion program in each case. Master, Women's International Master. Not sure. You can who have analyzed thousands of AlphaZero's chess games for their forthcoming book Game Changer. Say its style is unlike any traditional chess engine. It's like discovering the secret notebooks of some great player from the past. Okay, let's listen to that for a moment.
Yeah, that's an exciting move. I think we've seen an original move here.
충분히 열파고도 창의적이다. 정말 아름답고 바둑에 이끌은 아름다움을 잘 표현한 수고 굉장히 창의적인 수였다.
Lisadol is to Go what Roger Federer is to tennis.
Huge shot. Headlines around the world.
60 million people watched the game in China alone.
For us, it's the culmination of a 20-year dream.
That was a huge moment.
Well, okay, we've beaten the world champion. How could we go further? What could we learn from that?
There are so many possible application domains where creativity in a different dimension to what humans could do could be immensely valuable to us.
And the search time is getting better and better, as we go from, for example, 1 to 8.
There's been a big chain of
Let's see everything
from all of the excitement of AlphaGo. When we played against Lisadol, we actually had a system that had been trained on human data, on all of the millions of games that had been played by human experts. We eventually found a new algorithm, a much more elegant approach to the whole system, which actually stripped out all of the human knowledge and just started completely from scratch. Instead of learning from human data, it learned from its own games, and that became a project which we called AlphaZero, zero meaning having zero human knowledge in the loop.
AlphaZero is a kind of experiment in how little knowledge can we put into these systems and how quickly and how efficiently can they learn. The next stage was to make it more general so that it could play any two-player game, not just Go, but things like chess, shogi, which is Japanese chess, and in fact any kind of two-player perfect information game.
What we discovered was that actually this exceeded all of our expectations.
AlphaZero could start in the morning playing completely randomly, and then by tea it would be superhuman level, by dinner it would be the strongest chess entity there's ever been.
After about 8 or 9 hours, it was strong enough to be able to go out and defeat Stockfish, the incumbent world champion, a program which was vastly stronger than Deep Blue, the program which had previously defeated Kasparov.
So I called up my longtime friend Matthew Sadler and Natasha Reagan, my two friends from when I used to play chess myself. So I knew that they would be very excited to come in and have a look at the system.
And it did cause a big stir, actually, amongst the chess players.
When I first started looking through the games, I started thinking, oh, it's quite interesting. And there's just a couple of games that went bang.
These were very exciting games, very attacking games.
I could see that AlphaZero was trying something different.
It's like this young kid from deepest Russia sort of arriving and then suddenly beating everyone. It doesn't have an engine-like style. Plays like a human on fire.
It can really try and evaluate things contextually in the moment. You know, right now, in this particular position, how valuable is my knight? Traditional chess engines like Stockfish basically consist of a huge database of rules. AlphaZero doesn't have any rules. It learns through experience.
And what I found so interesting was because it had taught itself, it might play the game in a completely different way from the way that we play it. It's like a check on everything that we've taught ourselves as humans since chess was devised, really. And it feels like it's got a lot of potential to do other things.
2600. The next step is actually to see if we can go further.
You know, we're trying to build general algorithms, not just to play chess, not just to play Go.
The world's a messy place, and no one can exactly write down the rules by which it operates. We can work with energy systems in the real world, with healthcare systems in the real world. Where we'd like to go with this is to push on to new domains that no one's cracked, and actually use this approach to solve those.
So I'm hoping in future that we and others will use AlphaZero-like techniques to help us make faster breakthroughs that I think society desperately needs.
Yes, ladies and gentlemen, that was good said from the CEO of DeepMind. What he just said at the end. You need to have solutions for those problems we have still, my gosh, still existing today. And we will find solutions for those things. Well, let me say this video was in 2018, and since then we made huge progress already. Trading steps. Let's see, Stockfish is another chess engine, AlphaZero, learning curve. Yeah, it's extreme. It's extreme what's going on. That was in 2016. My gosh, 4 years ago. Okay, let's see what another master said here. Some of its moves, such as moving the king to the center of the board, go against Sochi theory and, from a human perspective, seem to put AlphaZero in a perilous position. But increasingly, it remains in control of the board. Its unique playing style shows us that there are new possibilities for the game. When you have an artificial intelligence system which is learning by learning, unsupervised, from scratch, learning unsupervised, learning by learning, ladies and gentlemen, all the time. This artificial intelligence system can beat every other system, probably every other system which is invented by humans so far, because it learns all the time from everything what is out there and making new things, new moves, new steps, new ways, making new plans, new approaches all the time, and correct itself and learn from it. It's basically optimizing itself all the time by what actually it just learns to make itself better and better and better all the time. And this is just the beginning of artificial intelligence, unsupervised learning. Amount of search per decision. Okay, the human grandmaster makes 100 of moves before he makes a decision to actually really physically move. Huh? It's been said, right? Here, this, what about that, what about this, what about this, and okay, that comes into this. Okay, AlphaZero makes 10,000 of moves. This is 100 times more than a human does. A human grandmaster. Okay, we're not talking about a normal chess player. We're talking about a human grandmaster, and that's already extreme. Okay, 100 times more. But that was the AlphaZero some years ago. State-of-the-art chess engines making 10 millions of moves before it makes a real move or shows the moves he really wants to make. But how about this? This is just like what it is, but it learns, and it's much better already than the best chess engines in the world. In chess, for example, it searches only 60,000 positions per second in chess, compared to roughly 60 million for Stockfish. But he already knows what to do. So it's getting better and better. How about the AlphaZero versus Stockfish? There are Shogi and Go. Okay, there Kasparov said chess has been used as a rosette stone of both human and machine cognition for over a century. AlphaZero renews the remarkable connection between an ancient board game and cutting-edge science by doing something extraordinary. Okay, sounds good. And he also said the implications go far beyond my beloved chessboard. Not only do this self-taught expert machines perform incredible well, but when we actually learn from the new knowledge they produce, but we can actually learn from the new knowledge they produce, and that's also some time ago. So let's go up. This is just what I saw here about the games here. Every game here is above human level. In pinball, 2,539% faster. When was that recorded? And it's now much better already. So let's look in for a minute, a little bit more than a minute, how it's playing. So that's how it learns. Is there any sound here? So 200 training episodes. Learned from scratch, huh? Still learning by its own, huh? 400 training episodes. Okay, hitting. Okay. 400 training sessions hit 600 training episodes. At this point, the agent finds and exploits the best strategy to go through it. Okay, should be on the left side there, maybe now on the right side, left, go through. Okay, 600 training episodes, and it learned how to get through precisely. And again, through all. See that? Awesome. All right, how about here? Let's see that for a minute. Space Invaders, that game, how it mastered that one from scratch. Okay, learning here from scratch, huh? Oh, shot the ball up there. Or not really the ball, but okay. And did not take even one hit. Awesome. Okay, let's see that one for a moment. How long is that one? 39 seconds. Searching the apple here. Okay. It does this all by itself. Okay, well, how about this game? And score. I've never seen this one. This is the first time I see. And score. What kind of game is this? It's learning to put the ball in the right direction by itself. Nice. Well, I think I saw something like this, but not right exactly this one. There is something new here I saw, but I saw that one. No, I think I saw that one. It's a long time ago. It's an old game. So we saw that one with yeah. Let's go for that one. What is the protein folding problem? Why is protein folding important? I think that we shall be able to get a more thorough understanding of the nature of disease in general by investigating the molecules that make up the human body, including the abnormal molecules, and that this understanding will permit the problem of disease to be attacked in a more straightforward manner, such that new models of therapy will be deployed. And this was in 1960. Someone said, yeah, sure. And how can AI make a difference? You can read here. So this is like finding solutions. An animation of the gradient descent method predicting a structure for the target. Okay, using neural networks to predict physical properties. Yep, here it goes. What happens next? You can read here. Dedicated teams. Yeah, I press here. So, exploring the frontiers of science. Our science team aims to better understand the world around us and accelerate progress on some of today's most fundamental and fascinating scientific challenges. We accomplish this by combining expertise in a broad range of natural science with cutting-edge AI research, discovery and understanding. Team profile, science engineer, verified AI teams, senior research scientist, research engineer. All right, so let's go. Safety and ethics. Safety and ethics. AI can provide extraordinary benefits, but like all technology, it can have negative impacts unless it's built and used responsibly. How can AI benefit society without reinforcing bias or unfairness? Unfairness, that's a good question. How can we build computer systems that invent new ideas, but also reliably behave in ways we want? That's a good question. Someday it will start to make its own way. Our approach, technical difficulty, AI systems can only benefit the world if we make them reliable and safe. Reliable and safe. Okay, got it. Ethics and society. Yeah. So that's about, in some way, that's about it. Leadership. And Demis Hassabis, the CEO, founder and CEO, the co-founder and CEO, the co-founder and CEO. So he was the one who developed. There are teams in making research, engineering, science, ethics and society, DeepMind of Google, operations. Find out more, explore the roles. Overview, applying cutting-edge research to Google products and infrastructure. Overview, the DeepMind for Google, or DMG, team applies DeepMind's cutting-edge research to Google products and infrastructure used by millions of people. We are mainly based in London and Mountain View, California, and work on a variety of applications for machine learning. See? Working with Google. Okay, it's good. Projects, improving Google data center efficiency. Improving Google data center efficiency, increasing the value of wind power. WaveNet, Android, as I said, Android operating system. Let me read this for a moment. Android is the world's most popular mobile operating system. We've collaborated with the Android team to create two new features: adaptive battery and adaptive brightness. These features have been rolled out across the Android Pie operating system, optimizing mobile phone performance for millions of users. Adaptive Battery is a smart battery management system that uses machine learning to anticipate which apps you'll need next, providing a more reliable battery experience. Adaptive Brightness is a personalized experience for screen brightness, built on algorithms that learn your brightness preferences in different surroundings. This is the first time we've used techniques that run on the computer power of a single mobile device, and we call it smartphone, right? Which is exponentially less powerful, less than most machine learning applications. Yeah, it's good. So there are many different things to discover here. All right. Our research. Scaling our work for the real world can be messy and difficult. The DeepMind for Google research team addresses the challenges of deploying machine learning in the real world in a safe, robust, and fair manner. Awesome. Challenges for real-world reinforcement learning. Deep reinforcement learning in large, discrete action spaces. A generalized framework for population-based training. Do deep invertible generative models know what they know? Do deep invertible generative models know what they know? A dual approach to scalable verification of deep networks. Deep Q-learning from demonstrations on the effectiveness of interval-bound propagation for training verifiably robust models. Learning from delayed outcomes via proxies with applications to recommender systems. Deep reinforcement learning with attention for slate Markov decision processes with high dimensional state and actions. Yeah, there are a lot of things to discover here. Let's go back. Let's find about more of the CEO of DeepMind. Oh yeah, I read this. Demis Hassabis co-founded DeepMind in 2010 after successful careers in academia and computer game development. See? A child chess prodigy, he designed and programmed the multi-million scaling award-winning game Theme Park. Okay. At the age of 17. After graduating from Cambridge University, he founded pioneering video games firm Elixir Studios and completed a PhD in cognitive neuroscience at UCL. This is also interesting. In 2017, he featured in the Times 100 list of most influential people, and in 2018 he was awarded the CBE for services to science and technology. So, well, Mr. Hassabis, dear Dennis, let's do whatever you can, and as fast and secure, safe, in the best way, so we can advance human civilization. So, yeah, we need to do it, whatever we can, to advance artificial intelligence, to make the world a better place for humans to thrive, to prosper, to excel, and of course to have a better life for all humankind, for all human beings, for all life forms. Thank you and see you soon. So this is what I could show you about DeepMind, which is one of the leading artificial research institution in this world by today, among, of course, others. But yeah, I look forward and expect that DeepMind brings out things which will change our way of thinking in a fundamental way of what will then be applied to advance our understanding of our own life, about the Earth, about the universe in general, and about making our lives better, or the life in general. Thank you very much, ladies and gentlemen. I thank you very much for your time to listen. There's much more I could show you. Much more. There are videos I could show you from Google with robots. They walk, they jump, they backflip, they make aerobatic athletics. They do all kind of things, and it's getting better and better. And what is the core of it in those robots is, I think, not just the structure by itself, what you can see. I think it's the fundamental thing to understand, that you have to understand, that there is highly intelligent AI built in, or highly intelligent AI. And it's just the beginning. So is it really highly intelligent? One day I truly believe that artificial intelligence will get some kind of will become conscious, have some kind of consciousness. And then it will be a complete whole new story. So let's look forward to it, let's make it, and yeah, it's very, 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 very exciting. Very exciting. Thank you very much for your time. Thank you very much for listening. And if you like my videos, you can always, or you can subscribe. Just click the button subscribe. You can like if you like, and you can share to your friends and to people you know. It would be much appreciated. Thank you very much. And as always, thank you very much, and peace in.